My courses are absolutely free of charges. My courses are going to help the students who are preparing for CSIR, NET, GATE, NT exam, PhD exam, SET exam, TIFR, Jest, IIT-Jam, and other exams related to physical science. Okay. So this is the lecture number 13 of thermodynamics and statistical mechanics. Okay. And also guys, I would request the students who haven't subscribed my channel yet, please subscribe my channel and watch my free live lectures which are going to help you to crack the exams related to physical science. And also guys, please share my lecture details with your friends so that they will also be able to watch my free live lectures and will be benefited from it. Okay, so let's get started. Okay, so there's a question. Question is, so we have been given two energy levels, okay, two energy boxes, and this energy of this level is E1 and this level is E2, okay, and in this energy level only N1 equal to 1, means only one particle can stay, okay, and in this energy level N2 and E2, the two particle can stay, okay, N2 equal to 2, and the degeneracy of this G1, this energy level is 2, and for this for E2 energy level, the degeneracy is G2 equal to 2. Okay, so we have given A, B, C three particles, A, B, C and C three particles. Okay, these are distinguishable particles. Now we need to find, so these are the energy level, and in this energy level only one particle can stay, in this energy level two particle can stay, so n1 equal to 1 for it, n2 equal to 2, and degeneracy for e1 is 2 and degeneracy for e2 equal to 2, and abc are three particles which is given, and using mb statistics or maxwell-boltzmann statistics, we need to find out this omega, that is possible microstates. Okay, omega we need to find using MB stat. Okay, in short I'm writing MB stat, it is Maxwell-Boltzmann statistics. Okay, so there's a formula guys which you need to note down. Okay, and if you know this formula you can easily solve, you can easily find out the value of omega microstate. Okay, and this is omega value is for Maxwell-Boltzmann statistics, the value of omega is n factorial, that is total number of particles. Okay, n factorial, n factorial, okay, n factorial into this capital pi, this is a product, okay, product of gi to the power ni upon ni factorial. Okay, so this is the formula guys which you need to note down. Okay, for Maxwell-Boltzmann statistics, the value of omega, that is microstate, is n factorial product of, this is product, okay, capital pi sign, this is a product like sigma is sum, right? Similarly the product of gi to the power ni, okay, gi to the power ni upon ni factorial. Okay, ni is the number of particles, gi is the degeneracy. Okay, and capital N is total number of particles. Okay, so for this case we'll just directly use the formula. So value of omega is going to be, the total number of particles are 3, so this is 3 factorial into, we can write like this, 3 factorial into gi, for gi is this one, for this is 2 to the power 1 for this energy, 2 to the power 1 is going to be into 2 to the power 1 into 2 to the power 1 upon this one, Ni factorial, right? Ni is this for this energy level, Ni is 1 factorial, okay, into this one, that G2 is 2 to the power 2, 2 to the power 2, or I can, yeah, 2 to the power 2 upon 2 factorial, okay, because we can write this one, omega equal to this n factorial into G1 to the power n1 upon n1 factorial into G2 to the power n2 upon n2 factorial, right? We can assert these are the values. Because this is product, okay? This is product. So this is going to be 3 into 2 into 1 into, this is 2 to the power 2 is 1, 2 to the power 1 is 2, and 1 factorial is 1 value, and 2 to the power 2 is 4, and 2 factorial value is 2 into 1. 2 will get cancelled, and this is going to be 3 to the 6 3 the, okay, it's this one, this 4 to the 8 3 the 24. Okay, so value of this microstate, that omega is 24, okay, 24 for it, okay. So very simple for this is for Maxwell, this MB statistics, okay. So this is, there are three formula, one for Maxwell-Boltzmann statistics, and another for Bose-Einstein statistics, and then the third one is Fermi-Dirac statistics, okay. Okay guys, so this is for MB, this is for MB stat, this is for MB stat, okay, Maxwell-Boltzmann stat. Okay, a good question, it's a good question guys. Okay, so next question is, this one. So we have been given two energy levels, okay, two energy boxes, that is E1 and E2, okay. For this N1 equal to 1, G1 equal to 2, and N2 equal to 2, and G2 equal to 2. Okay, so this is for the same question, but so here we have to find this microstate for MB statistics, okay. And here in this question, these are three bosons, okay. These are three distinguishable classical particles, okay. Distinguishable classical particles, okay. And for this, these are bosons. So we have three bosons, okay. And three bosons, okay. The bosons, they are identical and indistinguishable, okay. So now we have to find out this one, the omega. Yeah, we need to find out omega for three bosons. So for boson, we are going to use, so it is for classical particle. For getting the microstate, we will use MB statistics or Maxwell-Boltzmann statistics, okay. And for this question, because these are three bosons, for boson, for getting the possible microstate, we will use this one, Bose-Einstein statistics. Meanwhile, just let me check whether I'm audible or not. Okay, I'll check it later. Okay. So now, so I'll first I'm going to solve it manually, and then I will use formula. Okay. So we have E1 and E2. Okay. E1 has degeneracy 2 and E2 has degeneracy 2. Okay. We have three bosons. So how we are going to arrange it? One is here, and one is here, and because so in this energy level there should be two particles. Okay, so two are here, and 0 is here, right? So means the total number of particles is 3, right? Second possibility is this one is here, and then these two are here. Okay. Third possibility is uh, this one here, and these two here, and this. Fourth possibility is this one here. Okay, and this two here. Okay, so these are 1, 2, 3, 4, 4, and the fifth one is here. Okay, so this this is blank. One is here, one is here. Okay, the third one is this one. One is here, one is here, one is here, and one is here. Okay, so these are because in this level the maximum particle should be 2. Okay, so these are degeneracy, right? So one is here, two particles. Okay, so these are 1, 2, 3, 4, 5, 6. So value of omega is 6. Now I'm going to use the Bose-Einstein statistics formula. Okay, and then I'll find this omega value directly. Okay, by formula. So this formula is important, guys. So you need to note down. Okay, the formula is okay. The formula is omega equal to, you need to note down, guys, this formula and memorize it, guys. Okay, and solve questions using this related to this formula, so that you can easily remember those formulas. Okay, okay, so omega equal to this one, Ni plus Gi minus 1, Ni plus Gi minus 1 C Ni. Okay, this is the formula, guys. So Ni plus Gi minus 1 C Ni. Okay, where Ni is number of particles, Gi is degeneracy. So here in this case you can see N1 is 1, N2 is this, and this one, right? And there is anything missing? Yeah, anything missing? That is this pi. Pi is this capital pi. This is product. Okay, product of this. So for this energy level, this is going to be N1 equal to 1, Gi equal to 2, right? So this is going to be this one. This is formula, guys. You need to note down. Okay, and this is for Bose-Einstein statistics. Okay, I'm writing in short. Bose-Einstein statistics. Bose-Einstein statistics. Okay, so this is going to be omega value is this one. Ni is for this energy level. This is 1 or Gi is 2, right? So this is going to be 1 plus 2 minus 1 C, number of particle for this is 1, right? 1 into this Ni for this 2 and 2. Okay, 2 and 2. So this is going to be 2 plus 2 minus 1 C n is 2. Okay, so if you solve it, so this is going to be 3 and 2 means 2C1 plus, oh sorry, my apologies, into this is going to be 4 means 3C2, 3C2. Okay, so we'll solve it. So this is going to be 2 factorial upon 1 into 1 factorial 2 minus 1, right? this simple calculation into 3 factorial upon 2 factorial into 3 minus 2 means 1 factorial, right? So if you solve it, so this is going to be 2 into 1 upon 1 into 3 into 2 factorial we can write into 2 factorial into 1. 2 factorial will get cancelled, okay? So this value is going to be 3 to the 6, right? 6. So we have got by formula as well and we have got manually as well, okay? So this is the answer, guys. So this is the one. I hope you have understood it. So very simple. So we have found the possible microstate for bosons, okay? And for bosons we use B statistics, and this is the formula for B statistics. Okay, right? Directly we can put the value in formula and we can get it, or manually also we can get it like this. Okay. Next question. Next question is, so there is so we have this one, 3 energy levels, 0, E and 2E. Okay, these are energy levels, and we have been given Ni value is given, that is 3, and Gi value is given, that is 3. Okay, and we have 3 bosons. 3 bosons. 3 bosons. Okay, so 3 bosons, and now we need to find the omega value, right? Omega value, very simple. This is we'll use just formula because we will use Bose-Einstein statistics, right? That is uh, pi into plus Gi minus 1 Ni plus Gi minus 1 C2 Cni, right? This is for BE statistics, okay? I'm writing in short B, and this is Bose-Einstein. Value of omega is going to be, there is only one, Ni we have been given and Gi given, right? So 3 plus 3 minus 1 C Ni, that is 3, right? And so this is going to be 3 3 is 6 minus 1, right? This is 5 C3, and this is going to be 5 factorial upon 3 factorial into 2 factorial, right? So if you solve it, this value is going to be, this value, omega value is going to be 5 factorial means 5 into 4 into 3 factorial we can write, and upon 3 factorial and 2 factorial will open it, this is 2 into 1. 3 factorial will get cancelled, 2 will cancel this by 2. So this is 10. So microstates, possible microstates for this question is 10. Okay. Next is, okay, next is, next question is, so we have next question, and that is we have 3 energy levels, 0, E and 2E. Okay, we have 3 bosons, and we need to find out omega. Okay, that is possible microstates. Okay, and we have been given G1 equal to 1, G2 for this degeneracy is 2, or for this energy level degeneracy G3 is 3. This is boson means we will use uh, Bose-Einstein statistics, right? And the formula we know, that is omega equal to this one, right? Pi into, pi is product into, okay? Ni plus Gi minus 1 C Ni, right? So so there are three bosons, guys. Okay, three bosons. Three bosons means this Ni is 3, right? So this is going to be 3 plus 1 this Gi minus 1 C3, right? Into, for this 3 plus Ni plus Gi is 2 minus 1 C3 into this 3 plus 3 minus 1 C3. Okay, this formula. So value of omega is going to be 3 1 means 3C3 into this 4C3 into this one is 5C3. Okay, so we'll solve it. So this is going to be 3 factorial upon this one 3 minus 3 0 factorial into 3 factorial. Okay, okay, and then into 4 factorial upon 3 factorial into 4 minus 1, that is 4 minus 3 1 factorial into 5 factorial into this one 3 factorial into 5 minus 3 2 factorial. Okay, so if we solve it, this value is going to be this one. So 3 factorial will get cancelled, and this 3 will cancel 4 4, and 3 will cancel 4 5. So this I'll write in next page. So this is going to be 1 into 1 into this one 4 factorial means 4 into 3 factorial, right? 4 into 3 factorial upon 3 factorial into 1 factorial is 1 into this one is 5 factorial 5 into 4 into 5 into 4 into 3 factorial upon 3 factorial into 2 into 1 2 factorial, right? 2 into 1. So this 3 factorial will get cancelled. This is going to be 4 into 20 upon 2 10. So this is going to be 40. Next question. Next question is, we have two energy levels, okay, and this is E1, this is E2. Okay, meanwhile, just let me check whether I'm audible or not. Okay, it's not working. Okay, so this one E1 and E2 energy levels. Okay, so there is N1 is given 1, G1 is given 4. Okay, N2 is given 2, and G2 is given 4. Okay, so we have 3 fermions now. Okay, 3 fermions, 3 fermions, and omega we need to find out. Okay, and also we need to find S. Omega and S we need to find out. Okay, so this is so 2 energy levels. For here only one particle can stay, so one particle N1 is 1 and N2 is on 2 particle can stay. The degeneracy for this 2 particle is 4. Degeneracy for this energy level is 4, and degeneracy for this energy level is 4. Okay, so very simple. So and we have to, because it's a fermion, right? Statistics. Okay, so for Fermi Dirac statistics, there is a formula. Omega value is for Fermi Dirac statistics. Okay, that is Okay, guys, just wait. Three bosons. Three bosons. Okay. Yes, I'm audible. I'll proceed further. Okay, so this is for Fermi-Dirac statistics. Okay, so this formula. So we have been given the value energy, and N1 is 1, G1 is 4, N2 is 2, and G2 is 4. So I'll use this formula. So this is going to be omega equal to this one GI right. So this is 4 CNI is this number of particle is 1, right. 1 into for this 4C2. Okay, so we'll solve it. So this is going to be 4 into, okay, this is 4 factorial. Let's see, 4, right. We know that 4 factorial upon 1 factorial into 4 minus 1, that is 3 factorial, right, into 4 factorial upon 2 factorial into 4 minus 2, 2 factorial, right. We'll solve it. So value of omega is going to be 4 into 3 factorial upon 1 factorial is 1, 3 factorial into 4 factorial, we can write 4 into 3 into 2 factorial upon 2 factorial into 2 into 1. 2 factorial, 2 factorial will get cancelled, 3 factorial, 3 factorial will get cancelled. 2 will cancel this by 2 times, 2 3 is 6, 4 is 24. Okay, so 24 is the answer, guys, for it. 24 is the answer for it, okay. Twenty-four is the answer. Okay, so and also we have to find this S value. S value, okay. So S value means that's entropy we need to find, and that's very simple, guys, because we have a formula S equal to KB ln omega, right. So S value is going to be KB ln omega. Omega values we have found 24, right. Or we can write S equal to KB into, we can write ln KB ln 8 into 3 we can write, right, or we can write KB into ln 2 to the power 3 plus ln 3, right. And so this is going to be KB into this is 3 ln 2 plus ln 3. So value of KB and ln 3 into ln 2 value is 0.693 plus ln 3 value is 1.098, right. So we'll solve it. This value is going to be 3.27 kb. 3.27 kb, okay. So this value ln 2 value is 0.693, ln 3 value is 1.098, okay. Okay, next. Next question. Okay, so here I'm going to write some the functions, okay. So you need to note down that as well, okay. So I have already explained this, right, or the microstate value, the omega values for MB statistics, and this Fermi-Dirac statistics, and the Bose-Einstein statistics, right. Now I'll tell you the function, okay. So this one Fe for this Fermi-Dirac function, okay, for this Fe, that function, okay, Fermi-Dirac function, okay. So that is going to be, that is 1 upon e to the power beta e minus ef minus 1. Okay, so this is the Fermi-Dirac function, guys. Fermi-Dirac distribution function, okay. This is Fd Fermi-Dirac distribution function. Okay, you need to note down, guys, and learn it. Okay, this is Fe. So Fe equal to 1 upon e to the power 1 upon e to the power beta into E minus Ef minus 1. Okay, so Ef is Fermi energy. Okay, Ef is Fermi energy. Fermi energy. Fermi energy. Okay. Next is Fe. Is Fermi. This one is this is Bose-Einstein distribution function, and that is, guys, that is 1 upon e to the power alpha plus beta e minus 1. This is plus, guys. Okay, this is plus. This is plus, and this is e to the power and beta is 1 upon kt, we know, right? Beta equal to 1 upon kt. K is Boltzmann constant. Okay, so this is Fe equal to e to the power 1 upon e to the power alpha plus beta e minus 1. Okay, is the energy. So this is Bose-Einstein distribution function. Okay, Bose-Einstein Bose-Einstein distribution function. Okay, Bose-Einstein distribution function. This is for this is okay. So this is e to the power beta e minus ef plus 1. It is e to the 1 upon e to the power alpha plus beta e minus 1. Okay, for Bose-Einstein, this is minus 1 and this for plus 1. Okay, next, guys, next is for MB statistics, that is Fe. That Maxwell-Boltzmann distribution function is 1 upon 1 upon e to the power beta e plus a, guys. Okay, so this is MB, Maxwell-Boltzmann distribution function. Okay, Maxwell-Boltzmann distribution function. This is Maxwell-Boltzmann distribution function, and here you need to know. So this is MB Maxwell-Boltzmann distribution function. Okay, Fe equal to 1 upon e to the power beta e plus a. Okay, so here you need to note down main thing for Bose-Einstein statistics. For BE, value of A is minus 1. Okay, so here this is minus 1 for Bose-Einstein. Okay, and for Fermi-Dirac FD, value of A is plus 1. FD, we can see FD plus 1, and for MB Maxwell-Boltzmann, A value is 0. Okay, this is also important. So these are the Fermi-Dirac distribution function, Bose-Einstein distribution function, and Maxwell-Boltzmann distribution function. Okay. Okay, guys. Next is microcanonical ensemble, guys. Okay, microcanonical ensemble. Micro microcanonical ensemble. So this is microcanonical ensemble. Okay, so this is a figure I am going to make it. Okay, this one. This is isolated wall. Okay, so this wall is isolated, isolated, rigid, rigid, impenetrable, impenetrable, rigid, impenetrable, non-conducting wall, non-conducting wall. Okay, so this is isolated, rigid, impenetrable, non-conducting wall, and this is the wall, right? Conducting wall, right? So there is energy transferred. Okay, from here to here. Okay, so this is E1 and this is E2. Okay, so energy can transfer. Yeah. So here, guys, we need to know that omega E, omega, which is function of E, that microstate, that is going to be omega, omega E1, omega 1 E1 plus omega 2 E2. Okay, omega 1 E1 plus omega 2 E2, omega 2 E2. Okay, this is omega, that this omega is going to be, okay, total microstate is going to be microstate of this part plus microstate of this part. Okay. Next is, so here we can see E1 plus E2 total energy, this energy, because energy can transfer from one box to another, right? One part to another part, but cannot go outside, right? This is isolated, impenetrable, non-conducting wall. So cannot transfer outside. So here you can see E1 plus E2 equal to total energy going to be E, and that is going to be constant, right? Okay, constant. That is going to be, because total energy is going to be constant, because these walls are isolated, rigid, impenetrable, non-conducting wall. Okay. Well, now what we can do is we can differentiate it. So this is going to be E1 plus del E2, and this is constant, so this value is going to be 0. So from here, dE1 is going to be minus dE2. Okay. So here d omega value is going to be, this you need to understand, d omega, because we have this omega, right? This one. So d omega value is going to be, d omega value is going to be, this is del omega 1 upon del E1, and this is d E1, d E1 omega 1, okay, plus del omega 2 upon del E2, and this is going to be dE2, dE2 omega 2. Okay, dE2, my apologies, this is dE2 omega 1, dE2 omega 1, and this is dE2 omega 2. Okay, dE2 omega 2. Okay, so from here we can get this. Okay, so this is del upon del E1, del upon del E1, and this is ln omega 1, ln omega 1, that is going to be equal to del upon del E2 ln omega 2. Okay, del E1 upon del E1 omega 1 into equal to del upon del E2 ln omega 2. Okay, this is going to be equal, or this value is going to be beta, and that is constant. That is constant. Okay. Okay, so this is important question. That's equation. Okay. Next, guys, we know this. We can say equation one, and next we know this. We know that in by first law of thermodynamics, we know uh, du equal to TdS minus PdV. Right? This is by first law of thermodynamics. Right? TdS is del Q. Right? This one. So from here, what we can do is at constant volume, 1 upon T. This is going to be 0 at constant volume. So 1 upon T value is going to be ds upon d. ds upon du, and du is energy, right? So ds upon d. Okay, so this is important one. This is equation number 2. Okay, so now from here we can write, this is the one, right? So from here we can write s, and since we know s, that entropy is proportional to this one, ln omega. Entropy is proportional to ln omega, or we can write s equal to k ln omega, right? This is equation number 3. Equation number 2. Okay, k ln omega. So now we have this one, right? This b is constant. So from 1 we can write, del upon del e ln omega equal to constant, because this is constant, right? It means del upon del e ln omega is constant, right? This is constant. So and this is constant, that value is beta, right? Beta, beta. Or we can write, so here we can write this one. And now, so this is del. So from here, from this equation, from equation 3, from equation 3, from equation 3, from equation 3, we can get this one. From equation 3, ln omega value is going to be s upon k, right? S upon k. Ln omega value is going to be s upon k. So from 3, I can write del upon del e into s upon k. S upon k, right? And that is going to be equal to beta, and this is going to be del s upon del e into k, into 1 upon k, into 1 upon k, that is going to be beta. So from here, del s upon del e we have already found, guys, here. Del s upon del e, del s upon del e, this value is 1 upon t, right? So we can del s upon del, in place of this we can write 1 upon t. So this is going to be 1 upon t into 1 upon k, 1 upon k equal to beta. So here beta value is going to be, this is beta. So beta value is going to be 1 upon kt, right? This is important. From here we've got this one, beta value is 1 upon kt. Okay, and entropy, and this we have also know, this is entropy is k ln omega, or kb ln omega. Kb is Boltzmann constant, right? Here you need to understand this s is thermodynamic entropy, in short td entropy, okay? and this omega is going to be, omega is called statistical entropy. Okay, statistical entropy, statistical entropy. Okay, guys. Okay, guys. So uh, I'm going to wrap up now, and before wrapping up, guys, I would request you. So remaining part will do in next class. So before wrapping up the class, I would request the student who haven't subscribed my channel yet, please subscribe my channel, guys, and watch my free live lectures because I have completed many courses. For that, you need to check my playlist. Okay, so many courses have been completed. Okay, so and those courses are detailed courses, so just go to my playlist and watch all the lectures, and these lectures are going to help you for CSIR, NET, GATE, NT exam, PhD exam, TIFR, Just, IIT-Jam, and other exams related to physical science. Okay, and also, guys, please share my lecture details with your friends so that they will also be able to watch my free live lectures and will be benefited from it. Okay, guys. So thank you so much. Bye now.